Hello again, welcome back. For this video we're going to talk about an introduction to solving exponential equations. And an exponential equation could be something that looks like this. 3 to the x equals 729. And what makes this an exponential equation is that the exponent here is your variable. So we're going to be working to solve for the variable when the variable is the exponent. A couple things you need to know are some rules of exponents. And some of those rules are, for example, if I have 2 to the 5th power and I times it by 2 to the 3rd power, then that would equal 2 to the 5 plus 3 or 8th power. Compare that to 2 to the 5th power raised to the 3rd power. So 2 to the 5th raised to the 3rd is going to give you 2 to the 5 times 3, which is 2 to the 15th. Because we'll be using some of these properties in later videos, so you got to know these properties pretty well. But the first thing is, when you're solving exponential equations, you have to have the base number on both sides to be equivalent. So in other words, if I have, let's say 5 to the 7th power, I can say, well, that's equal to 5 to what power? If I have an x here, well, it's got to be x equals 7. Because if this base and this base are the same, then their exponents have to be the same or equal to each other as well. And I could change that again. I could say 5 to, let's say, the 8th power equals 5 to the, let's go with x plus 2. And you go, okay, well, the bases are the same. Then that means 8 must equal x plus 2. And that's actually what you're going to end up doing is you're going to go 8 equals x plus 2. You can drop the x or the base numbers off. Let the exponents equal each other. And now you can solve. And you'll minus 2 and minus 2. And you end up with x equaling 6. And now obviously you won't necessarily have to do this calculation with this simple of a problem. You go, okay, well 6 plus 2 is 8, and there's our answer for x. The more complex the problem becomes, the more you have to rely on setting these exponents equal to each other. Now the more difficult part is to take the number on this side, which is not a base 3 number, and make it a base 3 number. So we're going to show you how you can do that with a calculator. On your calculator, just press 3. Use your power button here, raise to, let's test 4. 3 to the 4th, and that equals, well, that only equals 81. So 3 to the 4th power is too low. So let's try 3 to the 5th power. 3 to the 5th power is only 243. So 3 raised to the 6th power, and oh, there we go. So what we can do first is bring down the 3x, 3 to the x, and rewrite this as 3 to what power gives you 729. And we've already figured out what it was on the calculator. Remember, it was 3 raised to the 6th power, so it's actually 3 to the 6th power. So when you go to solve this equation, you see that these two bases are now equal to each other, therefore the exponents are also equal to each other. We'll try that again with another one. Let's say I have 4 to the x equals 4096. So the first thing I'll do is bring down my 4 to the x. I want to see if I can get this into a base 4 number. So in other words, 4 to what power will give me 4096? And then you go back and you rely on the calculator a little bit. So let's do 4. Let's raise that to the 5th power. 4 to the 5th power is only 1024, so it's a little short, so I'm going to do 4 to the 6th, 4 raised to the 6th power, and that equals 4096. So I know that this is a 6th power, therefore my x here has to equal 6. Okay, here's a little bit more complicated problem. 6 to the x plus 3, so now I have two terms up here, is equal to 7,776. So the first thing you're still going to do is bring down the left-hand side, 6 to the x plus 3. And I'm going to try to figure out if I can rewrite this with a base 6 number. So I'm going to put equals 6 to what power is going to give me 7776. And you can go back to the calculator again and try it out. 6 raised to the 5th. Oh, hit it on the first try. So 6 raised to the 5th, so I put a 5 here. Now here's where the algebra comes into play. Well, I have like bases already, so now you're going to cross those bases off and take each of the exponents and let them equal each other. So x plus 3 is equal to 5. Okay, it's just like saying if I have 4 to the third power equals 4 to the third power, well, that means 3 is also equal to 3. So these exponents are equal to each other, so I'm going to let that one equal that one and just continue solving. So when I continue solving, minus 3, and I end up with x equals 2. So if you want to check to see if this is right, take this 2, put it back up here in place of x. So 6 to the 2 plus 3. 2 plus 3 is 5. And we already know that 6 to the 5th power, 6 raised to the 5th, does equal 7,776. Therefore, we know that this number checks out. Try another one here. So we've got 4 raised to the 3x plus 4 power is equal to 16,384. So what we want to try and do is get this rewritten as a base 4 number. Okay, so we'll bring this one down, 4 to the 3x plus 4. Okay, now you can sit with your calculator and you can do a little trial and error. So take 4, raise it to a power, see if that works. 4, raise it to a power, see if that works. But there is another shortcut. We can use logarithms to help us out here. And specifically, we can use the change of base formula. What that means is if I have 4 raised to some power, which is what we have here, and I want to know what power does that have to be so that it equals 16,384, there's a shortcut calculation. We got this button right here that says log, that's short for logarithm. And if you want to find out what this is, the box is going to equal, or in other words, the variable is going to equal log of 16,384 divided by the log of the base I want it to be in, so log of 4. You don't have to worry about what logarithms mean, just know that this actually does work. So we'll show it right here on the calculator. So we're going to put 16,384, maybe. And all we're going to do is press the log button, and it's done some kind of crazy calculation out here. You don't need to know what that is right now. Then we're going to hit divide, because that's next. Divide by, and then we're going to hit 4 in the log button for that one. So there's the log of 4. And all we got to do is hit equal, and we see, oh, that's actually a 7. So 4 to the 7th power equals 16,384. So I can come down here and put my 7 in. Okay, now I've got my bases the same. Once the bases are equal, I know that the exponents of 3x plus 4 has to equal the exponent of 7. And then I just continue solving like a regular linear equation, minus 4 on both sides. So 3x's are equal to 3. Divide by 3 on both sides, x equals 1. And if you want to be absolutely certain you did it right, take this 1, substitute it here. 3 times 1 is 3. 3 plus 4 is 7. And 4 to the 7th power, just double check again, 4 raised to the 7th power. And you can see it does equal our 16,384. So we know that 1 is our solution.